So in the previous video, we ended with this control system block diagram. So I wanted in this video to just go through how we can get the output of this system. Okay. So again, what I'm going to do is I'm going to just look at the signals instead of trying to reduce the entire control system. So here the signal is RS. What's the signal at this point? I know that by looking at the signal here, and to do that, I look at the signal here, and that is ys. So ys plus ns is the signal here. So that's y plus n. I'm just skipping the s's. So the signal at this point then is going to be r minus y plus n. And the signal at this point is going to be gc times r minus y minus n. The signal at this point then is going to be gc r minus y minus n plus td. So the signal at this point is going to be this term multiplied by g, right? So what do I get? So I get g times gc r minus y minus n plus td is equal to y. Now, while deriving this transfer function, I've just assumed that the feedback gain here is equal to 1. But you could do the same thing with feedback gain. Let's say if you had a gain h here, you could have done the same maths with that. So instead of y plus n, you would have get y plus n multiplied by h. I'll leave you to do that. So let's reduce this equation. And what do you get? You get g times gcr minus g times gcy minus g times gcn plus td equal to y. This means we get g gcr minus g gcn plus td equal to 1 plus g gcy. So you can write then ys equal to g gc over 1 plus g gc r of s minus g gc 1 plus g gc n of s plus 1 over 1 plus g gc td of s. So that's going to be your output in terms of the input, the noise, and the disturbance. And in the next lecture, we're going to look at how we can reduce the noise and the disturbance.